Okay, so this is the solution to question 6 of the 2012 Leaving Cert higher level physics paper, question 6. Okay, so we have Joe Kittinger jumping out of a hot air balloon, falling back to Earth. So he was up at 31 kilometers. There's lots of details in the stuff there. Okay, so calculate the acceleration due to gravity at a height of 31 kilometers above the surface of the Earth. Now, important here is that they give you the radius of the Earth as well at the bottom of the question. So we have 6.36 by 10 to the 6 meters. The altitude is 31 kilometers. So it's 31,000 meters. Acceleration due to gravity. So acceleration due to gravity is big G, gravitational constant, divided by the mass of the Earth, divided by the distance squared, or the radius squared. So if you go to page 46 of your formula book, your log tables, you get the gravitational constant, which is 6.6742 by 10 to the negative 11. Okay, we're going to multiply that by the mass of the Earth, which is given in the question to be 5.97 by 10 to the 24. And then we are going to divide that by the total distance squared. So it is the original distance, the radius of the Earth, plus the 31,000. And that's going to be squared. Okay, so let me get my calculator here. So I have 6.6742 by 10 to the negative 11 multiplied by 5.97 by 10 to the 24. Okay, that's my thing on top. Dividing that by 6.36 by 10 to the 6 plus 31,000. That's going to be squared. And I get an answer of 9.756 meters per second squared. Remember, that's acceleration due to gravity, 31 kilometers up. Okay, it's kind of there compared to the marking scheme. That's fine. What downward force was exerted on Kittinger and equipment at 31 kilometers, taking their total mass to be 180 grams or 180 kilograms? Okay, so we just have force is mass times acceleration here. So what is the downward force is the 180 kilograms multiplied by the acceleration due to gravity at that height. So you use the number you just got. I'm actually going to use the big long version of it, times 180, which gives me 1755.93 newtons downwards. Well, it actually says what's the downwards force. I didn't need to write downwards. That's fine. Estimate how far he fell during his first 13 seconds. Okay, so he's starting off at 0 meters per second. He has got an acceleration of 9.756 meters per second squared during his first 13 seconds, isn't it? Yeah, so we have a time. Lovely, so I'm going to use S is equal to UT plus a half AT squared. Because my U is 0, I'm just going to do straight into a half of 9.756 times 13 to be squared. So 0.5 times 9.756 times 13 squared is 824.382 meters. That's how far he fell downwards in the first 13 seconds. Okay, what was his average speed during the next 4 minutes and 36 seconds? His average speed. Okay, so that relates back to the question, because they tell us that that after 13 seconds his chute opened and he traveled down to 5 kilometers. So it was my 31,000 kilometers minus that distance, his starting distance, 382, minus 5,000. Okay, so that's going to be my distance that he's traveling, and I know the time as well. I'll get to that in a second. 824.382 minus 5,000. So he actually fell a distance of 25,175 meters, 0.618 meters. So that's the distance. The time taken, 4 minutes and 36 seconds. So the average speed, I'm going to go with v for velocity because I like it. Distance over time, so 25175.618 divided by, come on, I can do this in my head, 460 is 240 plus the 36, 276. I don't trust myself. Especially when I'm not being recorded. 276, is that what I said? I think it was. Okay, back to the calculation. 25175.618 divided by 276 seconds gives me an answer of 91.22 meters per second. Okay, on to part 5. How much was the force on a hemispherical parachute of diameter 8.5 diameter? So radius 1 is 4.25 meters. Radius 2 is 0.9 meters. So what's the force? So the I skipped a question. For part 3, you are asked, what assumptions did you make in the calculation? U is 0 and acceleration is constant. So yeah, there is no change in the acceleration. Even though technically as you fall closer to the Earth, you do speed up because your gravity force due to gravity gets stronger.